Okay, now that we have learned all the different ways to factor, we are going to put all the different ways together, and some problems you may need to use more than one method. The order that you should always go, though, is you should always look for your greatest common factor first, then check for your difference, and then it may be one of the other three methods. Your difference of two squares, or it could be your trinomial, where the number in front of x squared is 1, or it could be your trinomial where the number in front of the x squared is not 1, it's bigger than 1. So always look for GCF first. So if you look at this first example, your greatest common factor has to be common to everything in that expression. So notice all three terms have a number 4 that I can divide out. I also see all the terms have an x. So 4x is your GCF. Then in parentheses, we're going to write what's left. This 4 is out. I had an x cubed, I'd factor out 1x, so you're left with an x squared. Plus 20 divided by 4 leaves me with a 5. I had an x squared, only one x was factored out, so this still has an x left. Plus, just go in order, 24 divided by 4 leaves me with a 6. This x has been factored out, so no more x's there. So there's my first step. Now you always check to see if what's left over is one of these other three. It may not be, but you want to check. It can't be your difference of two perfect squares because I have three terms and it's not a minus problem. It looks like it could possibly be this one right here. Remember this one? All you do is set up your parentheses. If it's x squared, it's always going to be x and x. You need to find two numbers that multiply to 6 but add up to 5, and that would be plus 2 plus 3. Don't forget, this 4x still needs to be part of your final answer. So this would be the completely factored form of this problem. Okay, I'm going to have you put 2 more problems onto your notes. The second one, copy down this into your notes, 9x squared minus 9. Same thing, we always start with the GCF. So I only have 2 terms. I notice that there's a greatest common factor of a 9. Both the terms have a 9 I can divide out. And there's not an x in both, so I can't pull out that x. So I'm going to factor out a 9. That leaves me with x squared minus, remember when we factor, we're dividing. So 9 divided by 9 leaves you with a 1. Then you always need to check, look at what's left over in the parentheses, and is it one of these other three? So check, could this be my difference of two perfect squares? Well, I see a difference. Can I take the square root of x squared and 1? Yes. So set up your parentheses. It's x, x. The pattern is plus, minus. The square root of 1 is 1 and 1. Don't forget to put this 9 as part of your final answer. So again, it's a two-step problem. Okay, the last problem that I want you to add to your notes is this one. 3xy minus x squared. Again, we always start every problem the same way. Look for a GCF. I don't see any number besides 1 we don't need to pull out that's common to both of them. But I do see both terms have an x, so that is my greatest common factor. So I'm going to factor out the x. That leaves me with a 3 and a y minus, I had an x squared, one of them is factored out, so you're left with just this x right there. And remember, you always need to check now, can I keep going with this, what's inside the parentheses? So look back. Well, could it be your difference of two squares? Well, I do see a minus sign, I do see two things, but I know I can't take the square root of 3 or this x or this y, so it can't be the difference of two squares. Could it be one of these? Nope, because I don't have an x squared there. It's just 3y minus x. So this is a one-step problem, so you are done.